All right, ionic and covalent bonds. First thing you have to look at is what is bonding together. Is it a metal and a non-metal, or is it two non-metals? Let me draw my stair-steppy line so we can identify our metals and our non-metals. Okay. Metals are on the left, non-metals are on the right. And so I think of it like this. If I have something like sodium and chloride is the classic example. If I got something on the left, they will transfer their electrons to the thing on the right. Okay, like that. So they actually give up their electrons, mail it over. You can have it. Okay. Whereas if I have two nonmetals, like over here, fluorine and oxygen, they're close enough to share electrons on the periodic table. It's just a good way to think about it. Now, the only oddball on this list is hydrogen. Hydrogen and helium, they don't play by a lot of the rules as the other guys on the periodic table. Yes, hydrogen is on the left-hand side. It is an alkali, but it actually, anytime hydrogen bonds with anything, it is going to be covalent. It shares its one electron. It doesn't want to give up its one electron. And so it will share that electron gradually. It's only got one electron. It hangs on to it. So hydrogen will be covalent. So looking up here, we have our first one. We got hydrogen and sulfur bonded together. Well, immediately you see that hydrogen, you're thinking covalent. So let's put COV, and they share. I'm going to put an S for share. Okay. Second, we got barium and fluoride. Well, I've got barium over here and fluoride. So I got a metal and a non-metal, and they're not close enough to share, so they transfer over. They transfer the electron. So that's going to be ionic transfers. I think of the word co and covalent as sharing. That's like co-authoring, cohabitation, co-worker, coexisting. You share things, okay? So ionic is where we transfer it over. You know, this one down here, barium, we're transferring it over here to the fluorine. Carbon and hydrogen, well, hey, there's hydrogen again. Immediately, covalent. Oh, by the way, up here with barium and fluorine, barium is always going to be the one losing the electron. Fluorine's going to gain the electron. That's important to know, okay? Barium, when it loses that one electron, it's got the electron goes bye-bye, and so it's got one more positive charge than it used to have. It's no longer balanced. The negative charges went bye-bye, so it's left with a positive charge. And the fluorine has gained that electron barium gave up, and so it's going to have a negative charge over here because it's gained one more negative charge than it used to have. All right. We got nitrogen and oxygen. Well, they're over here right next to each other in the periodic table, so that's co. They're sharing, so that's covalent. So they're sharing as well. It's covalent. Let's put an S up here and an S up here. And then magnesium and chlorine. I got magnesium over here on the left-hand side. It's mailing it over here to chlorine. So they're not close enough to share on the periodic table, so that's going to be ionic. We're not going to use the co word with that one. Ionic, and it is transferring. And again, in this case, magnesium is losing an electron, and so they're going bye-bye. So this is going to end up with a negative charge. I mean, a positive charge. I'm sorry. It's going to have a positive charge. When the negatives go bye-bye, what it leaves behind is a positive charge. And because chlorine is gaining the electrons, it's gaining those negative charges, chlorine is going to be a negative ion.